I'm Jacqueline Nolis. This is my talk on when your data science projects fail. Before we go into projects failing, let's just talk a little bit about me. So I've been a data scientist for over 10 years. I co-founded a data science consulting company, so I do consulting. Before that, I was director of analytics at a consulting company called Lenati, where there was no data science team and I grew it from scratch. Before that, I was lead of advanced analytics at a consulting company called Promontory. I have a PhD in industrial engineering. I won a reality TV show. I'm married to the brilliant Heather Nolis. And for fun, I like to make funny data science models. So a selection of the companies I've done work for: T-Mobile, Expedia, Microsoft, Airbnb, DWSW, Univic, blah, 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 and more. So you look at that and you're like, wow, this person's really successful. They've done a lot. They look really good. And it's like, okay, but was that actually about me? And I think you see a lot of introductions to people that are like that, especially on LinkedIn. For some reason, LinkedIn's the worst. It's all of that. But, it sounds prestigious, but there's no hint that there's any difficulty ever there. It was all success. It was all TV deals. It was all of that. But, people really don't talk about failure much, do they? You go to LinkedIn, they don't really talk about it. They talk about how successful they were, or if they talk about failure, it's about how the failure made them successful. And that's kind of wild. And it really makes you think. So I got the thinking emoji. It makes you think. So it's what is a failure? Let's just define that, especially in data science, because it means so many things. But for me, a failure is when you set out to do some sort of data science task and you don't do it for one reason or another. So that could mean anything from okay, I have a good idea for a project, but then whoops, I can't even find data to do it. The data doesn't actually exist. Or, okay, I got the data, but the model doesn't fit. It doesn't really work. There's not a signal there. Or, we built a super cool tool, and the stakeholders never used it. The code was never touched, and eventually got retired. These are all different forms of failure. They're different ways in which the work you set out to do was not completed. So failure can mean a lot of different things in data science, and there are more there than the ones I listed. Those are some of the big ones. It can mean a lot of different things. And failing is the worst. I really just want to stress this. One, it hurts, right? Because you set out to do something, and if you did not succeed at it, it really makes you feel like it's about you. Two, it's embarrassing, right? Because it means other people see that you couldn't do the thing you wanted to do. And that's not great. And it ends your fun projects. If it was really cool to try and build a neural network to predict, animal names, and that's still not working, but it's still fun, to fail means I no longer get to do that fun thing. That's a real bummer. I'll just keep working at it for another 5 years. So, what's important is that you learn from your failures. And, when I was a junior data scientist, I had this thought a lot. And maybe you guys have had it too. Of you do something, it doesn't work. You're well, maybe if I was a better data scientist, I wouldn't have failed. And when I was a junior data scientist, I had that thought a lot. But now, as a senior data scientist, I have that thought a lot. Maybe even more. So it happens, but failure, it happens everywhere all the time. I see lots of heads nodding already. So other people fail. It's a very common part of being a data scientist. You can learn a lot when these things go wrong. You can learn things that will help you avoid that failure the next time. You'll find a new interesting way to fail. So you can avoid some problems that you have previously. But to do that, it really requires vulnerability. And that means both emotional, you have to be open and honest with yourself about what happened, how you were involved, how you weren't involved. And it's career vulnerability, right? I can go around and make a presentation about failing in data scientists because I've been around the block, but if it's your first presentation, you probably don't want to go out onto a conference and tell everyone that you did not succeed at your first thing. So it's really hard, and there's a lot of risk there. So I get it. And I fail a lot, and I think about this a lot because I see other people fail too, and it's hard for me. And when you have a lot of feelings, what do? You write a blog post about it. So I wrote a blog post about this a year or two ago on Medium. And I write a fair number of blog posts, and this became my second highest viewed blog post of all time, which means it resonated. A lot of people have these feelings too. And so I am primarily an R user. I don't do very much Python, sorry Python people. But if you're an R user, there's the best thing that can happen to you on Twitter. Does anyone know? Yes, that's right. You get a like from Hadley Wickham. Or in this case, you get a retweet from Hadley Wickham. So Hadley Wickham retweeted this blog post. I felt super great about myself. Okay, I did it, I succeeded. And then I went back and I looked when I was making this presentation, and actually in that blog post, I never actually mentioned my own personal failures. I just talked about the concept. So despite me making this big presentation right now about being vulnerable is important, I actually didn't do that in the very blog post on this topic. So like even I really struggle with the idea of telling people about how he failed. So with that, the next part of this presentation, I would like to walk through like the top 5 failures I've had in my career, with the hope that maybe you all will learn a little something about this that can help you, both in terms of you can try and avoid the ways I failed, and you will learn a little bit that, hey, maybe it's okay if we talk about this stuff more. Okay, I get a little nervous getting into all these, but here we go. Okay, so top 5 of my career failures. Number 1, the Adler alert. So this is my first month in my first job in industry. It's before data science was even termed. I was in the analytics department of an e-commerce company. It's a company, they sell lots of custom products. And they sell lots of these products, and one day, just one Tuesday, they were not selling as much as usual. They just noticed sales were down. And the business people, the marketing people were like, why are sales down? There's a problem here. And eventually, days later, they found a bug on the website. But the marketing people hated this. They're like, it is not our job as marketing to notice that sales are down and notice that there's a bug on the website. There should be tooling, or there should be something that will say, hey, there's a problem because there's something wrong with the signal. And so an executive who was one of these people who noticed, emailed my team, which was the forecasting team, and the work got trickled down to me, of like, the executive was like, hey, we had a problem on the Tuesday, please email me the last 5 Tuesdays worth of sales, and I will look at that and try and understand how this Tuesday was different than the other 5 Tuesdays, and we can show that there's something we can do here. And I was a month into my job, and as you guys probably maybe started to notice, I'm kind of a loud person, and so I could have just said, okay, here's the data. But instead, what I said was, hey, this is actually a deep, interesting statistical quality control problem. What you can do is you can say, well, each day of the week, there's like a seasonality there. There's a seasonality over the course of the year. And the sales are going up over time. And there's a difference between sudden big problems like bugs and like slower burning bug problems like, new products aren't launching as well as expected. So there's all these different trends and signals in here. And this is kind of what the data looks like. Each point is like a day of the week. And so this is near the end of the year, so it's like sales go up and up and up, and you lose a lot of sales after Christmas because people stop buying stuff, and then you have a huge drop on New Year's. And so like some of these dips and stuff you'd expect, but then like maybe this one right here, your tool, your anomaly detection tool will say, okay, this anomaly we can't explain, it's a seasonality problem. So when I built this, my maiden name was Adler, and so I created a tool using statistical quality control, time series. People bought into it. It was great. Somehow, because it didn't have it named, it got the name Adler Alert. So it got named after me, which is not, don't ever have this happen to you. Because if that happens to you, that's bad. Because that means anytime something goes wrong, they look at you and it's your problem. That's not good. So it was named after me. And I built the tool. And so you listen to the story. You're like, that sounds like a great success. Career, I would post about this on LinkedIn. Data saves the day. That's a great success. Except, so here's the truth of what actually happened. So all of that was true. But after that happened, the product didn't actually work at all. And here's why. We have this anomaly detection tool, and people are quickly like, okay, do it for sales, for revenue, for average order value, do it for all of those by 3 different regions, make a spreadsheet that has a tool that has all of those at once, and then look at that every day. And so, if you think about that, if you split it 80 ways, then with even like a p-value less than 0.5, some of those every day are going to be bad. And then I was a month into my first job. I didn't know anything about UI design, and as a person who has a background in math, I'm like, oh, the UI doesn't matter. It's about the model, about the tool you build, not about how you present it. And so what I did was I just made an Excel spreadsheet that had a row for each day of the week, or each day of the year, a column for each metric we're looking at, and different shades depending on whether or not they were good or bad. And so each day you have to look at the row, and you have to be like, well, is this shade of orange enough that I should be worried? How does that compare to the other shades of orange? And the tool was totally useless. And so despite putting all this work into building a model, getting it named after me, no one could actually get any value out of it, and the tool was ultimately scrapped without providing much value. And so I learned there that no matter how much time and effort you put into building a good model, the work actually won't succeed if the implementation isn't good. And so it really is important that you think a lot about how are you going to build a good UI? How are you going to make sure you limit this to just a few KPIs so it doesn't quickly get diluted in usefulness? All of those things are thoughts you should be having at the beginning of the project, not after you've done a lot of the statistical work and then are trying to figure out what to do with it. So that didn't go great. And then, not related to that, for various reasons, I left that company and moved on. All right, So what happened next? Okay, failure number 2, a full customer analysis. So pretty quickly I moved from working in industry to being a consultant. So I worked with various companies and people would bring us in to help them with data. And we were working with this retail company. And they had years and years and years of these transactional data. So they know what every customer bought for like the last N years. They had in-store surveys, they had the emails that went out, who clicked on them, they had all this data. But what they didn't have was a data scientist. They never had one of those before. And like most executives, the executives working there had read all these business articles about data is the new oil, and data scientists are going to change your company. And so they brought us in and they said, hey, can you have a data scientist look here and tell us what's useful? And I was a data science consultant. I believed in the power of data. They brought me on. I'm like, yes, great, awesome. And so I started taking these different data sets and joining them together, finding relationships, finding new and interesting insights in the data. And I was very excited. I thought there was a lot there. And I went to go present this to the executives. Wow, that sounds like a success, doesn't it? That sounds great. But it turns out it was actually a huge failure. This is like one of my most embarrassing presentations. You can see me cringing. That's a real cringe. And the reason why was I walked into that meeting with all the executives and I presented things like, hey, do you know if your customers buy product, the customers that buy product X are more likely to spend high amounts on things? They're like the high spenders. They're like, yeah. And the executive's like, yeah, we know. We walk into the stores every day. We see the people looking fancy buying those products. And I'm like, oh, yeah, I guess you knew that already. Okay. Well, how about this? Did you know that, and I show a graph like this, and I know that the higher number means they're more likely to recommend your company. Do you know that the people who are more likely to recommend your company are more likely to say that your service was good? And it'd be like, yeah, we do know that. That's actually kind of obvious. And so what happened was that despite me being a data scientist, finding relationships in the data, and going through all this work to find out what I thought was interesting, I had very little grasp on what these executives cared about and what was interesting to them. And so by just running in and looking at data, I lost the critical component of seeing what their issue was. And so what I learned there was projects can fail despite having great data, building great models, building great reports, because you don't have a clear objective, right? So having a goal that you're setting out to do, beyond just find something interesting, is really important if you want your project to succeed. Okay. So every time I click, I'm like, oh, this is a good new one. This is a good one. Here's a good one. Failure 3, automated QA testing. Okay. So I was, again, doing some consulting work. And I was consulting for a company, think a big tech company, that was releasing lots and lots of different apps. For whatever reason, they had many apps. And these apps, they had a whole building filled with people whose whole job it is to click on like every part of the app and test it and make sure it works before you launch it. So like a whole set of humans whose job is just click and make sure things are okay. And when they click, these apps have telemetry in them, meaning there's lots of data being collected that this person clicked this button in this place at this time. You're collecting all this telemetry data, and it'll be something like this. Like, at this time the app was started, at this time this button was clicked, at this time the app connected to the server, and you get like terabytes of data like this. And the company had an idea of, let's use the telemetry from the app to try and tell if it will pass or fail one of these tests. And if you can get that going well, you don't need as many humans to do the testing for you, because the telemetry will be, you build a machine learning model on the telemetry and you will tell if it passes or fails the test. And so this is actually a joint venture from 2 different teams. The quality assurance team of the company, so the people whose job it is to like work with those building flow of testers, and the data science team, the people who just work with machine learning models all day. So they're going to work together. So that was the idea for the project. And so I got brought into this project like, months into it already. I came on as a consultant, and like 3 days in, I'm like, oh my god, this project will never, ever work. And why was that? Because, when you're a data scientist, as I learned, one of the first things you want to do is really like, not just look at data, but try and understand the problem. And so there are like 200 different tests they wanted to automate, and I actually looked through the list of 200 tests that people have to go through, and they'd be tons of things like, make sure the grammar was correct on the menus in the apps. And like the telemetry will probably not even have the wording of the menu in it, never mind be able to tell you if that is good grammar or not. So like, to try and use telemetry to solve that would not really be feasible. And for many, many, many of these 200 tasks, would we be able to make a machine learning model for it? And then, okay, of these terabytes of telemetry, few of them even had something that could be probably related to tests. So things like whether or not it's connected to the server at this time, what is the temperature of the processor of the phone or computer, like these things, most of this data isn't actually super relevant. And then the business required an intolerable model accuracy, right? So even if we could build a machine learning model, to get it so that the business was confident in the model, it would have to be like 99% accurate, right? Or agree with humans 99% of the time. And trying to build a machine learning model that can agree with humans that much is just super hard. So one of the tests was actually check if the app has telemetry built into it, which you think would be the easiest test to do. And even on that test, we could only get like 90% accuracy with, or agreement with humans. So like, not great. And so, okay, you're like, okay, this project's not going to really succeed. This seems pretty infeasible. Surely they'll just cut it off, right? And it turns out that this was this project lasted for a year because of a Nash equilibrium. And why was that? Okay, so we have two teams. The quality assurance team and the data science team. And so if one team says, this project is never going to work, then the other team's just going to be like, you aren't team players. Of course it will work. Give us promotions, please. Get them off. So in this, you get this Nash equilibrium with only one team says we should quit, the other team looks really good. If both teams say they should quit, that's okay. But if they both continue, that's technically the optimal thing, and everyone's just suffering. And so this went on for a year before finally someone senior enough to cut it off. And so it just was a really sad situation. And so I think one lesson here is that the project can fail just because of poor leadership. If there's some politics going on, it doesn't matter about the data scientists or anything like that. Another reason why the project could fail is just, even if you have terabytes of data, there might not be a signal in there that is relevant to the problem you want to solve. So just having data often isn't enough. I like to say a lot of situations, when you're in this problem, here's one kind of solution you can take to make it better, but in this one I just quit, so I don't know if I'm a good answer to what to do here. Okay, failure 4, predicting Kickstarters. So, a few years ago, I was online and I was looking at, Kickstarters are like places where, a Kickstarter is a website where you have these campaigns for products that are going to not yet be launched. And people can have like a 30-day window to put in money, and if enough people put in money, the product is launched and everyone buys that product, like water bottles or board games or things like that. And so, as part of this, if you're a couple days into the campaign, you don't know if it's going to succeed or not. And so someone built a website that would try and predict this many days in whether or not the project's going to succeed. And it turns out that that website used a really simple formula, which is they took the current number of days as like and assumed like the same rate of buy-in until the end of the campaign. So if we're 10 days out of 50 in and we've earned $10,000, then we expect by day 50 we will have earned $50,000. And so I thought about it, and I'm like, well, okay, if you're a Kickstarter campaign, there's actually more, it's probably not going to be a flat line of people putting money in, right? Because people probably put a lot of money in at the start of the project, or the start of the campaign, because they're like, oh, this is new and exciting, I want in. And that kind of dips, and then near the end, you're like, oh, we haven't made our goal yet, please give us money, please give us money. And so there's probably like a hump at the beginning and the end. And so I'm like, I'm a data scientist. I emailed the guy who ran this website, and I'm like, this would be a fun side project. Could I just see the data you have and see if I can try and improve it and do better than just taking the current value and assuming that constant rate? So I emailed the person. They were very friendly. They sent me data back. And this didn't work out. So I worked on this for like weeks. For weeks, I tried to beat that super simple flat line assumption, and I could not. Or like for weeks, I couldn't. And it turns out, it's like, okay, sometimes you're at the start of a project, you have that hump where a lot of people buy in, but sometimes you don't. Sometimes not many people know about it yet. And sometimes you have that big hump at the end, but sometimes you don't. And there's like 8 other ways they're actually all different. And so if you try and fit a model, it usually doesn't do that well, or just ends up being a flat line. And so I ended up putting in all these weird features, like, well, if it's between day 7 and 10, and if it has at least this, and eventually, after putting in all of these features, I eventually got it that my model was very slightly better than that flat line. And so I'm like, okay, I emailed back to the person who ran the site, and it's like, look, here's my model. It does slightly better. Here's the super complicated formula behind it. You need R to run it. Good, have fun. The person didn't email me back after that, and like, I wouldn't have emailed me back either, honestly. So I get it. So I think there's actually a couple lessons here. One is, be prepared for your models to not be accurate. I think it's often the case that you're going to try and build a model and it's not going to work out, but don't go in with the assumption that just because you're a smart data scientist, you can do better than something. Sometimes it just turns out the data isn't there for you. Another lesson is that I didn't really, again, think about the implementation. I was, at that point, I was like a a data scientist, but I had very little experience with putting things in production. So I hadn't thought at all about APIs or Docker deployments or anything like that. I just handed off R code because that's what I was used to doing to people, and that just wasn't the right solution there. So sometimes thinking about how you're going to deploy stuff really matters. And this failure beguiles me, because whenever I give, I'm thinking about this, if I'm giving a talk like this, I always I should really open up that data set one more time, and really just maybe today, with my years more experience, I could do better than that flat line. And I'm pretty sure I couldn't, and I'm pretty sure that'd be a huge waste of my time, so there's some value in knowing when it's time to cut it off. And my last failure is about retail customer simulations. So again, I was doing consulting work, and I was consulting a lot for retail companies. And if you're a retail company, a thing you really care about are being smart with coupons, right? If you give out a coupon, you really want to make it that when you give out the coupons, people will come in and buy more than they would have had they not received that coupon. You don't want to do things like give coupons to people who already spend a ton of money and who are about to go in your store anyways. You also don't want to give coupons to people who will never even come in. So you want to be smart about coupons. You want to know their value. And typically what companies do to find out the value of coupons is they make an Excel spreadsheet, super simple Excel spreadsheet with a bunch of assumptions. Right? We're going to give out 50,000 coupons. We're going to assume 10% of people actually come in with a coupon. So 5,000 people come in. And we're going to assume each person spends an extra $50 with that coupon. And that's their formula, and that's the value of that coupon. And so when I learned this, as a data scientist, I'm like, that doesn't feel right. Anytime it's a simple formula Excel, it doesn't feel right. So I came in as a data scientist, and I'm like, okay, well, here's what we should do, right? Let's get ready. Here's what we should do. What if we made a simulation where we actually simulated each customer making purchases, and then we looked and understood how a coupon would adjust how that person behaved, and use that simulation to make a prediction. So let's use some machine learning. So I made months creating a tool to do that. It would take customers from the database. It would simulate millions of actions. It would adjust those actions based on hypothetical coupons and roll it up to a result. And all that was done using machine learning. And I was working at a consulting firm, and companies paid us real money to use this tool. So I built a tool. We got money as a consulting firm for this tool existing. Feels great. I'm feeling great about it. Except, so we sold this tool. And we sold this to a company, and they were working with us, and we would run it and say, here's the results. And here's what would happen, is we'd hand them the output of our simulation, and the clients, they'd say, this seems interesting, but could you just take that output and make it in Excel formula so we can give it to our finance team? Because they don't get all this simulation stuff, and really just a simple Excel formula would be better. And so what we would have to do is create that simple formula that they would have done themselves and just try and make it that it roughly aligns with what our simulation did. And it ended up being almost exactly the same thing they would have done had they not had a simulation. So the simulation was great in that it sounded cool and innovative to clients. It got us sales and prestige. But it turns out the clients didn't want the most accurate and nuanced model. They actually had one simple goal with launching a coupon, and that's get finance to buy off on it. Right? And if your goal is, and finance will buy off on anything that doesn't seem like it's going to bankrupt the company, and so if your goal is to convince finance that this won't bankrupt the company, you don't want a simulation. You want a really simple, easy to understand spreadsheet. So I spent months on this, and it got the consulting company money, but it didn't do the goal of trying to make the coupon analysis better. So in that, I think it was a major failure. And so again, and I think this lesson comes up quite a bit, it's really important to make sure you understand what your customers need. In this case, the customer didn't need a cool simulation to get the most accurate results. They needed mediocre results that will convince finance it's fine. Yeah, that was fun. So those are my five failures. So what can we draw from these failures? How can we put this together? So I'd say, first off, lots of projects fail. I think 75% of projects fail. And I think the reason, and I make that up, but it feels like 75%. And the reason why is because data science is like research and development, right? You have a data set no one's looked at before, you're trying to do something no one's done on it before, and you're hoping to get a good result. You have to, it would be crazy, it would just be nonsense if you could do that 100% of the time correctly, right? If every time you got a data set, you could be like, I could absolutely prove this with that data set, let me show you. That's just not how the world works, right? The low-hanging fruit has been picked. And so as data scientists, we are looking for hard results. And so, because most of data scientists' work is research and development, failure is natural and not something you can really avoid. 2, I think there really are 3 big types of data science failures. You can find some others, but these are the big 3. 1 is that you just can't find enough relevant data, right? The data set you're hoping for existing in the company doesn't. If you do find the data, it's like only a year's worth, or it has some real flaw in it. So just like the data isn't there. There's not a signal in the data, or it's not right for the customer. And so yeah, if it's not relevant to the data, it could be things like it wasn't well collected, like we don't have the right tooling in place to actually collect the data we need. It's sometimes impossible to collect. Like for that coupon analysis, what you really want to know is how much are people spending at other stores, and that would just be impossible to really collect in a useful way. Or maybe disjoint over many systems, right? Your company may have that data, but it's held by 10 different departments, and the keys, the indexes and keys of each of those tables don't line up, and it's just too time-consuming to actually get the data. And so if this is your problem, you really just have like two solutions. One is you could try and create new data yourself, help build that new tooling, or you can try and find alternate data that can be a proxy for it. Unfortunately, usually if you can't find the data you want, an alternate one won't work as well, but you never know. Sometimes that data can be better. Two, there's not enough signal in the data. So sometimes there's just too much noise, right? If your data is so noisy, you can't predict any trend based on it. You can't. There's just too many outside factors. Like, one that people try and do a lot at retail companies is try and be like, can we build a model that's going to predict when the customer will come back, how many weeks or months until they come back. But like that is so dependent on things like their paycheck. If there's a sale going on, blah, blah, that just trying to do that with any reasonable fidelity is very, very difficult. And sometimes this data, the signal in the data never existed, right? If I took a 6-sided die and I rolled it 10,000 times and I handed it off to you and said, okay, here's the data of 10,000 die rolls, predict the next one, there is no signal in that 10,000 rolls about what is the roll that will happen next. And sometimes that feels like a toy problem, but sometimes that happens, or actually that happens a lot in business settings where it turns out that the signal just isn't inside the data at all. So this can be fixed sometimes by trying to find a better data set or just trying to retrigger the problem, but it's a pretty tough situation to resolve. If there's too much noise, if the signal never existed, it's hard to get a signal back. And then the third type, it's not right for the customer. So sometimes that means it wasn't validated, right? Before you started the work, you didn't really go in and say, hey, is this something you want? How would you use that? Sometimes you do that, and that's great, but sometimes you don't, for whatever reason, do that stuff. Sometimes there's no stakeholder, right? So if you're a data science team, it's really easy and natural as a data science team to be like, hey, I know it would be a really good idea if we had a model to predict when a customer is going to leave. And you build that model, it works great, but no one in the company asked for it. You built it because you thought it was interesting, and because there's no stakeholder, there's no person to actually take with and run with it. And that is a big problem with projects that come from internal data science teams. Also, sometimes it's just politics, right? Sometimes it's just for whatever reason, your team doesn't get along with that team, or isn't in national equilibrium with that team, and it's just difficult to resolve. Usually in these situations, the best thing you can do is try and change or pivot the product. So in the case of that Adler alert, that system to detect anomalies in sales, that actually never worked. But we did take a little piece of that and ultimately use it for a better forecasting tool. And so sometimes you can take a little bit out of your thing, and if you find a product that people do want, you can adjust it. So it's important to make the best of it. So when you do find yourself with a failure, one thing that's really valuable you can do is collect the positives. So Dewey Koning on Twitter just talked about how she recently had a failed data science project, and so what they ultimately did was got the team to sit down and write a bunch of things that they learned from the project. And so by actually forcing yourself to sit down and be like, okay, what went wrong? What can we learn from it? How can we use this as a better result? You will more likely avoid that situation again, and you just have a better collective understanding of what happened. This is often in software engineering called a blameless postmortem, where you do that without trying to point fingers, and that's a tool people really like in software development, works really well in data science too. Another thing you can do is just cut and run. Just cut and run. So something I see happen so much is on the data science team, you have a project and everyone can kind of see it's not really working. And usually it's like one or two people are focused on it. Everyone can see, including those one or two people, that's not really working. But no one wants to be the person who said, all right, let's cut it off. So people keep working on it. They're like, well, what if we tried this model? What if we tried this model? What if we had this data set? Blah, 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 blah. And you can do this for a long, 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 long time. And I have. But that's a huge opportunity cost, right? So first off, it's a drag on the team because it's just a bummer. And then it's a huge opportunity cost because those data scientists could be doing something more productive if they put this less productive thing down. And it can be really hard, especially as data science, like, just the idea that there's so many models out there, they're all interesting, you want to try them all. It's really hard to be able to say, you know what, this isn't worth the time I'm putting into it, but it's so necessary if you want to try and skip through those 75% of failures and get to the 25% successes. Okay, so I have a few more things to say, but one more thing I think that's really important is just at the start of my career, and I think a lot of junior data scientists do this too. At the start of my career as a junior data scientist, I really thought of data scientist as being like carpentry. How does carpentry work? Well, I guess there's like a person who builds houses, right? And that's the data scientist. They're there, they're building houses. And a junior data scientist, they build a small house, right? It's got like one door, 2 floors, a small house. And a senior data scientist, they build skyscrapers. They build these beautiful models, right? So a junior data scientist, they're there with their logistic regressions. And a senior data scientist, they're collecting all these different data sets into their deep learning neural networks on the GPUs, right? And that's how it kind of works. And what also happens with junior data with carpentry is that if you ever have a house that collapses on someone, you are out of the game forever, right? You're gone, right? Like, it is so bad to fail. That's why you start on little houses, because that's where you're going to succeed. And then you get promoted to skyscrapers, but you can't ever mess up. And that's what I thought it was like as a junior data scientist. Yeah, you can't let your building fall apart. You can't. Your products have to succeed. And so now that I've been around the block a few times, I don't think that's the real mental model that people should have as data scientists. And here's the new mental model I have, which is data scientist is like treasure hunting. And not just because that's more exciting, but as a data scientist, you're treasure hunting. And what do? You, as a junior data scientist, you're setting out for a small treasure, right? You have a little map, and you gotta go around one island, and you gotta find a small, easy to get treasure. And like, yes, maybe you'll get that treasure, but maybe it doesn't exist. And no one ever says, wow, that treasure hunter is not up to snuff, they didn't get the treasure. Like, no, that's just, if you got any treasure, everyone would be astounded. And as senior data scientists, they're like the same thing, only they know, or they're going to places that have dragons and skulls and crossbones, right? So you're still hoping to get treasure. You never know. And a senior data scientist is just more comfortable avoiding more obstacles. But they still have just as much of a chance of failure. As a junior data scientist, they are just taking on more difficult maps.
It's like Dora the Explorer.
Yeah. Dora the data scientist. Yeah. So yeah, and the best part is finding a treasure is fantastic. Everyone's excited. If you get the treasure, no one's super mad if the treasure didn't turn out to exist. So lastly, that thought I had at the beginning, I like to think of that as like weakest link syndrome, which is this idea that, hey, if I was a better data scientist, my project wouldn't have failed. It's not imposter syndrome, because like I believe I'm a data scientist. I just have, it's this somewhat different idea that like I am the cause that this did not succeed. But if you like step back a little bit, and you're like, okay, this project I work on, it did not succeed. Like, what about that? And it's like, well, it didn't succeed, but like I didn't design the database. I didn't put the signal in there. I wasn't responsible for getting the business, like, I was not the person who's responsible for getting the business people excited about it. There are so many different components of a data science project that the belief that the one reason why it failed was because of that one data scientist, it's like, if you think about it hard, it's kind of like, it would be wild if that were true, right? If data scientists, like, we don't have that much power. Like, we really don't, and that's great. And so, it's really not about you in a grand sense, when the project you're on fails. There's lots of things that go on. And honestly, if your work isn't failing, that's probably a sign that you aren't taking enough risks. Because if data science is so much about research and development, if all you're doing is the same repetitive tasks over and over that you know are going to work and get your executives to sign off on, then that's probably a sign you're not doing bold enough work. So with that, go forth and fail. Hopefully you feel a little bit more excited about failing after hearing so much about some of mine. Some closing notes. One, just because I feel obligated to do this, if you are looking for help at failing more, or maybe even succeeded, as I said, I work as a consultant, so do data science and AI ML consulting. That also includes helping teams grow, or starting data science teams, thinking about data strategies, and creating proofs of concepts of things. That's the website. And if you want to learn more about becoming a junior or a senior data scientist, I am writing a book with Emily Robinson, Right now you can go online and buy it, and 9 chapters are available. And the rest, we actually sent the rest of them to the publishers earlier this week, which we're super excited about. So the full book will be available in early 2020. If you buy it now, you get the full book when it comes out. And there's a discount code there. And the website to buy the book is bestbook.cool. Very memorable. So thank you.
Thank you very much. Do you guys have any questions?
What's your suggestion? Hi, my name is Luna. Nice to meet you. So, what's your suggestion on finding a cool, interesting side project to do? It's right now, like I want, to have some like side project to do, but I just like don't really have ideas like where to find data, where do I get this idea? What's your suggestion?
That's a great question. So the most interesting side project I ever worked on, I just happened to find because I was reading the newspaper and they mentioned a data set in it, and I'm like, I don't want to play around with that data set. And it turned out it was like something that you could get publicly available. And I think that happens a lot where the side projects come from just when you're doing your like day-to-day thing, you just happen to like stumble upon a data set and you get curious about it. And so I find that keeping an open eye, and if you see someone else using interesting data on their side project, you can also just take that and try it yourself. There's like no like dibs on this stuff. You can try and like just draft off people until you have enough time to have found some interesting ones on your own.
Thank you.
For number 5, it was the retail simulation. What year was that? And well, first, what year was that? Do I have a follow-up?
Oh, it was at the risk of incriminating the employer, like 2016 or 17.
Okay, because I was just wondering if you think that idea has changed over time. And now I don't even remember what idea I was asking about. I just wrote it down. But if you showed the slide, I could probably remember.
Okay.
It was whatever that lesson was.
Oh.
That they. Oh, I think it was that the finance team just they weren't interested in machine learning. Like with the advent of machine learning being sort of hot and.
So, okay.
Do you think that's changed?
So let me. This is going to be like a 30-second rant. So I'm sorry. It's gonna be a rant. It's just like. So I think it's always going to be the case that finance people just want simple formulas they can follow. So I think that's always going to be the case. I think there is a room for analytics and data science teams to do more things like advanced simulations to try and figure out, well, what coupon should we be using so we can decide which coupon's best, and we tell finance, well, here's a simple spreadsheet. So I think there's more room for machine learning, things like that. However, I think trying to understand what coupon is optimal is one of these projects where you know so little that you couldn't ever possibly get this one right? Because you never will. You will never ever know that the people who use your coupon would not have used your coupon had it not exist. Because you can't really just not give them a coupon and see what happens. And you're like, well, let's do like a test where we do half one and half not. They're like, yeah, but you can't make it, like it's really hard to make a situation where you generalize the lesson and they don't get the emails if they just click someone else's link or like, it doesn't get plugged. There's all sorts of ways. And it's getting even worse with loyalty programs where like you can never tell what would happen if the person didn't enroll because if you're a good enough customer, you will know about the program one way or another and you will enroll. And so I think the whole world of using data and data science and retail to try and truly find the value of things is just enormously hard and people act like it's really easy because it gets you consulting clients. So I think just like, it's one of these things that like I think we should all be a little bit more open that there are some problems that are really hard in data science, even with lots of data. Maybe that answered your question.
It did.
Okay.
Thank you.
Yes.
So, at the risk of so I'm not actually in industry yet, so I'm kind of curious about this. But say for example, you're starting to work with a client, and for this particular lesson, make sure you understand what the customer needs. There's a fair bit of negotiation and communication that needs to happen until eventually we get to an understanding of what a customer needs. Mm-hmm. What happens if you're deep into a project and they've been paying you, and then you finally understand oh, this is what you need. But then I put in all this effort to do this one thing, which is not what they need. How do you break it to them that I'm sorry guys, I'm not doing what you need?
So that's a great question. Great question. And the thing about being a good consultant is that that's actually that's awesome. You just got another sale, right? We did all that work. We did all this, like, look, you gave us tens of thousands of dollars. We did this analysis, and it turns out that this isn't actually, what you thought was important isn't important, which is great. That's super valuable to them, for them to realize what they think is important isn't. And then you're like, instead, what is important is this analysis. That would really help you. Please give me more tens of thousands of dollars. Usually, they are so happy you just told them to stop going down the path that isn't important, that they will then continue to hand you money about a thing that is important. So I think the real, there's situations you want to avoid where you're dishonest about it. Like if you go into a consulting gig and you're like, I will absolutely build you a model that will definitely predict which customers will churn, and then it comes to the end of 12 weeks or whatever number of months, and you're like, no, it's impossible. That's bad. Like you have to go into the expectation of like, we're going to try and make this, and if a month in we can tell it's never going to happen, we're going to cut it off. Like you have to put those sorts of like honesty levers in. But I think the idea that it turns out what they want isn't what they thought they want is bad is not true. Often it's good. Yes.
So on that same note, what have you learned about setting expectations and writing your contract scopes so that you put yourself in a good place to be in that level of trust that you can continue with that discussion and it doesn't feel like you're like not delivering on what you promised?
That is a great question. That's a great, and the thing I love about this is that data science, its field hasn't gotten to the point of software development yet where they can say, we have sprints and agile, and we don't know how long things are going to take. For some reason, data science is still, this analysis will take 2 months, and 2 people, and this many thousands of dollars, and we'll get this, we're still in there. And so I have seen multiple data science consulting firms not get this right and then lose money because of it. I think the best thing that you can do are, one, just as I was saying at the very beginning, be open and honest about, we don't know if this is going to work, we're all on this journey together, we're going to keep you posted. And the other thing is your contract, you can put in the contract checkpoints of like, if at this point we don't know, it doesn't seem like it's working, we can cut it off. Because this idea, like if you don't have those in, then you get to that point, you feel like you should cut it off. You can't cut it off, so you're like, I gotta make this work for 8 more weeks, and that gets progressively uglier and uglier. And then you kind of get into these situations like, where they're like, why are we still paying you? Why are we still paying you? And you're like, because the contract. And like, it's just, yeah, it's just not a good scene. So. Yes.
What's your recent failure you're trying to avoid? Those are from the past. So what's the reason for you?
Good question. So, not all of these are as far in the past as I would have liked, but honestly, so in consulting, I have a client I'm working with, and things were pretty successful. Like we had some big wins. We found some really interesting insights, and we were able to get execs really excited. And then, like, it's a weird form of failure where that works so well that nothing I am doing now is as good as that first thing. Like it's like almost like I did too well at the very first work and I've made that like less good than the next sequences of things. But sometimes I think as a data scientist, sometimes you just get into situations where you're like, there isn't anything else we can do with this data that is particularly important to you right now. And when you're in that situation, like it's kind of like that knowing when to quit thing. Like I'm kind of like, recently I've been in a couple of those knowing when to like, oh, maybe we should just put this down because even though we got some wins at the beginning, like it's clear there's probably not anything else there and we should switch to something else. But we were struggling to do that because that first win was so good that we don't want to like say, and then we can't have any more wins. So does that make sense?
Yeah.
Yeah. Yes.
I have a follow-up to that. I'm a junior data scientist right now, just starting out, and one of the things that you just said is, so like I'll work on a project for an interview or a passion project or something, and I struggle to understand what the stopping point is if it's not success. So like, if it's not one of these reasons to stop doing the project, like how, do you have any advice on knowing if your brain is telling you other data scientists would be able to find the pattern, or do you know what I mean? Like,
Yeah.
And I don't know if you guys struggle with that too, or if that
For, like,
goes
side
away.
for side projects specifically? Or
No, just any project, and I think, say your name again. Huda, I think, hit on it in
Yeah.
her presentation as well, of just, it feels like you don't know what to try.
Yeah. So that's a
So
great
how do you know
question.
if you've like exhausted all of your options?
Yes, so that's a great question, and then I can't believe I didn't put a slide on this, but my general test is, let's say I'm trying to do a prediction. I'm trying to predict the value of some quote we're going to make. I'm trying to make it a prediction. if I can do a simple logistic or linear regression and I see some signal there, that's a sign it's probably going to work out. But if I can't do, if my linear or logistic super simple method can't find some sort of signal, then no matter how fancy of a model I'll put on, it probably won't be able to find a signal either. It's like the fancy models will get that signal to be more noticeable, like it'll improve things, but it won't make something be there that wasn't there. And so generally I just try to, as quickly as possible, hit MVP of like, okay, there is something of value here, I can improve on it, and not get into, well, I haven't found anything yet, but maybe if I do something more, maybe. So really what I do is just try and as quickly as possible get to, okay, I've passed the risk of I can't actually find a signal.
Cool. Thank you.
That's a really similar question.
Yeah.
On-site projects, passion projects, when they've gone from there's some wins, and then there's been a period of failure, and it's no longer fun, but you're potentially still learning things.
Mm-hmm.
Do you have any suggestions on how long to carry on down the road? Well, it's not going that smoothly any longer.
Yes, that's a really great question. All of these are great questions. I keep saying. So my general endpoint, because I'm vain, is that my endpoint is a blog post or something. Like if I can be like, okay, I've put like published material out there in the world, I'll be like, okay, I've learned something, I have put it in a place where I've stored that, and I've put it in a place where other people can learn. So that really works well for me. I mean, I'm not great at this. Like, I'm not. I had a project. Let me tell you about a project I had.
That's not true.
Thank you. I had a project where I was building a website, and this website was to take 2 Twitter accounts and you mash them up into a new third funny account. And so I worked on this site for like 4 months. Like 4 months I worked on this. I got my friend who was a designer to make a design for it. I did all this work. I got it really pretty much done. And then I didn't touch it for 8 months. For 8 months I did not touch it. And then one day I'm like, I should just launch that. Because I was always like, well, I should have more features. I can't launch it yet. I need it. And I finally, it was like 8 months later, I'm like, I'll launch it. And I launched it to a group of my friends. Like I just put it on a private website. And my friend's like, this is the funniest thing I've ever seen. So I put it on a public website. It got so popular, it just kept crashing. It was having 3,000 concurrent views, 200,000 views in the current day. Wildly popular. I was having panic attacks because I'm like trying to fix all the really hacky things I did because I didn't think it would get that popular. And eventually it petered out and all that. But the reason why I'm saying I'm not very good at that is I spent 4 months working on it and then didn't get any value out of it. I just putzed around for fun. And then I spent 8 months not doing anything with that. And then it turns out that was actually by far the most famous thing I ever did. And I wouldn't have known based on the fact, I didn't treat it like that at all. And so, I don't know where I was going with that as a point. Except that, it's not by definition, if you put it away for a month, that's fine, right? It doesn't matter. The only person who cares is you. If you're working on it as a side project on your own, you're still learning on it, that's fine. If you're like, I wish I was learning something else, then go learn something else. There's really not, if it's a side project and not for a client, there's not really a bad way to do it.